Welcome to the presentation of red wine quality analysis. Now, the problem statement here is that we need to predict the quality of red wine based on certain psychochemical properties. And some of the properties given in this data set are citric acid, chlorides, total sulfur dioxide, pH level, and the alcohol content. And we need to predict the wine quality, which ranges from the value 0 to 10. Now, these are the psychochemical properties given for the red wine in this data set. Citric acid, chlorides, total sulfur, pH level, and alcohol content. Let's understand each of them in detail. So, coming to citric acid, it is added in wine to boost the acidity and complement the flavor of the wine. However, when we add citric acid excessively, it can promote unwanted microbial growth. Now, the chlorides are naturally present in the wine, but when there is a significant increase in the chlorides, it can create an undesirable salty taste, which will make the wine's market appeal very low. Now, coming to the sulfur dioxide is added, has antioxidant and microbiological stability to the wine, but adding too much SO2 will have adverse effective when we consume for certain individuals. Now, coming to the pH level, normally if the pH level of wine is between 3 to 4, and it should not go beyond that. And coming to the alcohol content, the normal alcohol content of wine is 8.4 to 14.9%. And wines with high alcohol content will have robust, bold flavor. But it is not desirable to have a very high alcohol content. Now, coming to our data analysis, this is the summary of the data which we have taken, the 500 samples. And the inference from this data summary is that the citric acid is slightly positively skewed. So we don't require any transformations, while the chlorides are positively skewed. It's very high positively skewed, and we need a log transformation in this case. When it comes to the total sulfur, it is moderately positively skewed, and we might require some transmissions like power transmissions. When it comes to pH, it's nearly symmetrical, and so no transmissions are required. And come to the alcohol content of the wine, it is also moderately positively skewed, and it might require transmission like power transmissions. When it comes to the quality of the wine, it's slightly positively skewed, so it doesn't require much of a transmission. Now let's look into the distribution of all these variables. So as you can see in this histogram plot, the citric acid and quality wine has some kind of symmetric distribution, while others are not that much symmetric. When you look the correlation plot or correlation between the other variables to quality, we can see a very slight correlation between some variables. Let's have a deeper understanding by having a correlation plot. By seeing this correlation plot, we can see that we have a good correlation, less correlation for citric acid with the quality, while it has good correlation with pH. So these two variables are having good correlations. So we need to either remove one of them. And coming to the other variables, they have very less correlation with quality, except alcohol content, which is having good correlation. Now, let's transform this data. Like if you see, we need to do a log transformation chlorides. We need to do power transmission for sulfur and alcohol, and we need to exclude pH level and then see the transmissions. So doing transmissions to chlorides, sulfur, and alcohol content, we'll see the distribution here. So this is after transmission, and below you see before transmission. So we don't see much of a difference in distribution. So now we'll see outliers are present in the data, which is causing this distribution to be less affected by the transformations we did previously. So when I check the outliers, I could see that chlorides have more outliers compared to the other variables which have very less outliers. So I need to treat the outliers. So I'm treating the outliers for chlorides, and you can see the outliers for the chlorides before and after outlier treatment. And you can also see the distribution of chlorides, the before outlet treatment and after outlet treatment. Now it is almost symmetric. And you can see the skewness of all the variables before and after transformation and before transformation. And you can see a major change in chlorides transformation, like from 5.3 it came to 1.56. Now coming to the data summary now after the transformations. After the data normalization. So we have did mean max normalization, and based on that, now we can see the summary. The minimum of every variable is 0 and the maximum will be 1. And you can see the skewness also shown in this presentation. Based on that, we are also again creating the histograms for based on the normalized data, and you can see almost all the variables are now in symmetry position. Based on that, we model the data. We used 4 models: the weighted arithmetic mean, the weighted power mean, with p value 2, and ordered weighted average. And based on that, based on these metrics, we found ordered weighted average has best model because it has the lowest RMSE. And from that, we can see the variable x3 and x4, which is here it is the total sulfur dioxide and the alcohol content is the most important variables, and you can see the weightage given to these for the OWA model. Based on that, we are predicting a variable, predicting the quality of the wine based on these input variables. So from the data set given, we use these variables: citric acid 1, chloride 0.7, sulfur as 40. We are not taking pH value here. Alcohol content is 8.3, and based on these input variables, using our best prediction model, we predicted the wine quality to be 5, which is a good moderate wine quality. Thank you.